Hello, third and fourth graders. Let's go ahead and start reading our next section in science. It's chapter 5, part 7, air's weight and pressure. We have a verse from Job, chapter 28, verses 24 and 25. For he looketh to the ends of the earth, and seeth under the whole heaven to make the weight for the winds, and he weigheth the waters by measure. Air has weight. You've probably heard the expression as light as air. You may have thought that air does not weigh anything at all. After all, air does not feel heavy, and that's true. We don't feel weight from air, but air does have weight. A cubic foot of air weighs just about 1 ounce. It would be impossible for you to measure air by itself, but you and a friend can try a demonstration, or you and one of your family members at home can try this. And it shows that air does have weight. The Bible talked about the weight of the winds in Job 28, verse 25. And long before scientists learned that air has weight. Since air has weight and takes up space, air is matter. Because remember, the definition for matter is that it needs to have weight and take up space. So let's look at this demonstration that they're talking about here. It's under the something to do. You'll need 2 large balloons of the same size, a yardstick, masking tape, and a 14-inch piece of string. Tie the string to the 18-inch mark on the yardstick, which would be middle of the yardstick is where you're tying it. Hold the yardstick by the string and extend your arms straight out. Does the yardstick balance? If not, adjust the string so it balances. So you want to start off with the yardstick being balanced with the string. Now, tape the string in place. Tape the 2 empty balloons, so don't blow them up yet, but tape the empty balloons 1 inch from the end of each yardstick. So we're taking the 2 balloons and taping them in 1 inch from the end of the yardstick. Hold the yardstick out again and wait for the balloons to balance each other. And this is where it's important that we have the same type of balloon, so don't have like a water balloon and a birthday balloon. Have the same type of unblown up balloon. Take each balloon off and blow it. Take 1 balloon, not each, 1 balloon off and blow it up completely. Knot the balloon and tape it in place once more. Now you have 1 balloon that's full of air and 1 balloon that's empty, taped to the yardstick. Extend your arm holding the yardstick by the string. Is the yardstick balanced? No. The end of the yardstick with the full balloon is lower than the end with the empty balloon because the air inside the balloon has weight. It's not much weight, but it does have weight. This amount of air is far lighter than the same amount of liquid or solid. So if we were to fill this balloon with water, it'd be way heavier than it is when it's filled with air. If we were to take sand, which would be our solid, and put it there, it'd be way heavier. So air does have weight. It's not the same amount as liquids or solids have, but it does have some weight. Air also has pressure. Because air has weight, it creates pressure. Pressure is the measurement of a force that matter exerts over a certain amount of area. Solids exert pressure. If you've ever pressed flowers, you've used the pressure of solid books to flatten out the flowers. Liquids exert pressure too. You can feel the force of water pressure if you put your hand on the end of a garden hose when it's turned on, or even underneath your sink when the water's falling down, you can feel that pressure. Gases also exert pressure. You may want to try the demonstration below in order to observe this air pressure. So let's read this demonstration. You'll need a glass, a flat piece of cardboard, and some water. You should do this demonstration outside or over a sink or a bucket in case anything goes wrong. Because with this one, it does work if you do it correctly, but sometimes we can end up messing something up and it can create a big mess. So be careful. So it says, fill the glass with water, run water over the cardboard so that it is wet. Put the cardboard on top of the glass. Hold the cardboard in place as you turn the glass upside down very carefully. So you fill the glass when it's facing upright and you get the cardboard wet and put it on top of it. And then you slowly and carefully turn it so it's upside down, as you can see here in the picture. Then remove your hand from the cardboard. So don't take the cardboard away, just slowly but surely remove your hand. The cardboard should stay there because the air pressure will hold it in place, keeping the water in the cup. And once again, if you're not careful or you rush through this or don't do it exactly right, it could end up making a mess. So if you want to try this, go for it, but just do it in a place where the water won't create a problem. Now, air pressure changes. Do you remember how far up in the atmosphere extends? Every bit of that air, which goes up for about 1,000 miles, has weight. The weight of all the air in the atmosphere creates pressure as it presses down. Air pressure is greatest close to the surface of the Earth. As you go up higher into the atmosphere, air pressure gradually decreases or becomes less. This happens because there's less air above to press down. You remember we talked about that our atmosphere goes up for about those 1,000 miles, and closer down to the Earth, we've got more air than we do farther up. Air pressure on Earth varies. If you are on top of a high mountain, like Mount Everest, the highest in the world, air pressure is less than if you are at sea level. Air pressure at sea level is about 15 pounds per square inch. So right now, no matter where we are, there's a lot of air pressure putting on us. And approximately 1 ton of air is pressing down on you. But how is it that you do not feel that ton of air? Since air is exerting upon you the same amount of pressure on all sides, you do not feel that pressure. If you've ever flown in an airplane, you may have experienced what it feels like when air pressure becomes unequal. When the airplane gets to a certain height, you can feel the air inside you pressing against your eardrums. When your ears pop, the pressure has suddenly become equal on both sides of the eardrum. And that's where, when we go flying, often people don't like that feeling because the pressure isn't equal in all around us. And so when our ears pop, then that pressure is equalized and it feels much better. You can observe how change of air pressure affects liquids by watching what happens when you drink through straw. The straw you put into a glass of liquid looks empty, but it's really full of air until some other substance fills it. When you put the straw into the glass of liquid, the liquid forces out some of the air and fills the straw to the same level as the liquid fills the glass. So some of the straw has liquid in it, and the rest of the straw has air. When you suck on the straw, you remove the rest of the air that's inside the straw. You suck up that air, and the air pressure inside the straw becomes less than the air pressure outside the straw. The straw works because the air outside the straw presses down on the liquid and forces it to go up the straw. If you put the straw in a container which has completely airtight except for the opening made by the straw, a straw would not work because the air pressure on the liquid would not be changed. And so that's where with like water bottles, often they will have little holes in them, so that way when you suck on them, it allows for that air pressure to be equalized. Also, when you think about if you have a cup that's got a straw in it, the top of the cup isn't completely solid except for the hole for the straw, and so that allows for that equalization. Or even if you go to a restaurant and they have the lid still has tiny holes where you put the straw in, which also helps to allow for that equalization of air pressure. Finally, for today, we've got a state bird to read about, and this is the California gull, and it's not actually the state bird of California, it's the state bird of, that's right, Utah. So let's read about it. The California gull is most famous for saving the lives of early settlers in Utah. In 1848, swarms of grasshoppers were destroying the crops, causing a famine. Flocks of California gulls suddenly appeared and devoured the grasshoppers, saving the crops and the settlers. Gulls are large birds with long wings and heavy bills. They are known for their shrill voices. The California gull is about 22 inches long, so just short of 2 feet. The adult is white with a mantle or black and upper wings of medium gray. The tips of its wings are black spotted with white, so we can see that here in the picture. The California gull is found from the northern prairie provinces of Canada, so up here in Canada, south to northwestern Wyoming and Utah, so this section here in Wyoming and Utah, and west to northeastern California, so you can see it along the coast there. It winters on the coast and migrates inland during the spring, where it nests in large colonies on inlets of fresh or salt lakes. So that's pretty cool. Have a great rest of your day.